Warning, the video you're about to watch contains mathematics at the level of pre-calculus. All material has an assumed prerequisite of college algebra and trigonometry. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, Professor of Mathematics at Cosumnes River College in Sacramento, California. This is another video for pre-calculus students who are going through the trig review material. Like most of the videos in this series, it is just a review. There's not a lot of meat on these lectures just because it's there to kind of remind you of the theorems and some of the identities, that type of thing. However, we are going to get into some slower videos where I'm actually teaching some things. This video is not one of those, although I do slow down a little bit, but it's the next couple of videos that are going to be like that. But let's remind you of some critical elements that are going to help you in calculus. So, arc length. In a circle of radius r, the length s of an arc that subtends an angle of theta radians is s equals r theta. So this is what this means here. You have an arc length s, you have a circle of radius r, and you have an angle that the arc subtends. So, and that angle is theta. Okay. So in the ratio, not the ratio, but the formula is s equals r theta. Let's go ahead and prove that here because I think that's worthwhile to do. If you take a look at that circle, as far as angles go, we actually cut out an angle of theta out of the entire 2 pi of that circle. I mean, if you really think about what that arc length really is, it's sort of a percentage of the circumference. Right? The arc length is just some portion of the circumference. And we know that that's some portion of 2 pi r because that's the circumference of a circle. What portion of the circle is it? Well, again, we've cut out an angle theta out of 2 pi radians. Now remember that angle is in radians, so we've cut out theta out of 2 pi radians. There are 2 pi full radians in a circle. So again, the arc length s, which is equal to a portion of 2 pi r, is going to be theta out of 2 pi times that 2 pi r. Again, that's the portion of 2 pi r. And if you multiply, or I'm sorry, cancel the 2's and cancel the pi's, you get the wonderful formula theta times r, or as I write it, s equals r theta. Actually, I think most people write it that way. So that is the proof that the arc length in a circle of radius r cut out by an angle theta is going to be s equals r theta. Again, it's critical to note that the angle that gets cut out has to be in radians. You're going to be tricked during exams and homeworks and quizzes and stuff like that when your professor hands you something that's the angle's not in radians, it's in degrees. They mean for you to convert that to radians first and then find the arc length. And here's a perfect example of that. This is a very classic problem. Pittsburgh, Pennsylvania, and Miami, Florida lie approximately on the same meridian. What that basically means is they're almost directly north-south of each other. That's not exactly true, but we'll just say it is. So they exist on this great circle is what we would call it. And that circle would be obviously the planet Earth. And they exist on different latitudes. So Pittsburgh is on a higher latitude, so it's somewhere up here, let's just say. And Miami is at a southern or more south latitude, I guess, or a lower latitude. But the angle between them from the center of the circle, so this is a sphere you have to imagine, and there is some arc within that sphere that leads to those two, and that angle between them can be measured because we know the latitude of Pittsburgh is 40.5 degrees and the latitude of Miami is 25.5 degrees. And so there is a 15-degree difference between them. So if I grab that blue ink and move it outside of that great circle. Terrible that I just done that like that, but whatever. We have 15 degrees here, and we want to know what this distance is. Oh, by the way, the radius of the Earth is roughly, not exactly, but roughly 3,960 miles. So there we have an angle and a side, so we should be able to find that arc length D, which would give us the distance approximately between those two cities. There's a lot of approximations here, so it won't give us the exact distance, but good enough. And actually, I'm going to call that distance S. Now, we know we have a formula, S is equal to R theta. We have an R, and we have a theta. The problem is that theta must be in radians, not degrees, but radians. So we're going to start finding the arc length, but we are going to have to make an adjustment. It's 3,960 miles times 15 degrees, which does not work. So we have to exchange degrees for radians. Because let me say it this way, if I left it like this and I did the computations, my answer would be degree miles or miles degree. And that makes no sense. But remember, radians is a unitless measure. And so when you convert to radians, you actually leave behind any semblance of a unit there. And so that will no longer say degree. It won't even say radians. We have to infer that it is a radian. So let's see, 3,960 miles. And then 1 degree is the same thing as pi over 180 radians. And so now we can go ahead and reduce this down. Let's see, 618 maybe, or 12. So let's see, this is 3,960 pi over 12 miles. And of course, you can approximate, just grab a calculator really quickly here. So those two cities are approximately 1,037 miles apart. Now, are they? No, probably not. But that's the basic usage of the arc length formula. A very, very powerful formula, actually. Now, I threw this extra example in because often you have to work with the arc length formula in two directions. One where somebody hands you a radius and an angle, and you have to find the arc length. And then this case right here, where I give you the radius and the arc length, and you have to find the corresponding angle. So let's make, it's totally fictitious, right? So you and 4 other friends decide to split a 12-inch radius pizza evenly. So a 12-inch radius pizza. Now, it's pretty challenging to cut this into 5 evenly sized slices. And for some reason, you're really selfish and you're like, I don't think I got the right size slice. So somebody cut it up possibly like this, right? There's 5 slices there. This person got the big win right there because that's the biggest slice. And let's just pretend as though, let's say that this slice is your slice. Let's just say that it looks like it's not an evenly sliced pizza, right? It's hard to slice things 5 ways. So being the astute math student and knowing this is a 12-inch radius pizza, you measure the length of the crust of your slice, this crust right here, and you measure it out using a non-rigid tape measure to be 12.5 inches. And the question is, did you get your fair share? In other words, did you get 1/5 of that pizza? Well, remember, arc length should equal radius times angle, and the angle is in radians. Well, the arc length here is 12.5 inches. The radius is 12, again, inches, and we don't know theta. If you divide both sides by 12 inches, the units actually cancel. So you just get 12.5 over 12 because the words inches cancel beautifully. And that's why radians is a unitless measure, because the units will cancel. And this, grabbing a calculator, is roughly 1.04 radians. Now I'm writing the word radians in because I want to tell you something about this. Or maybe I don't need to actually write the radians in, but I want to compare this because the fact is we know we should have 2 pi radians in an entire circle, and we're splitting that amongst 5 people. The angle that you have for a slice should be the angle that everybody else has for a slice. So what is 2 pi over 5? Well, 2 pi over 5 is approximately, I just have a calculator here, it's not like I memorized this, 1.26. So you definitely got shortchanged. You did not get as big of a slice as you deserved. So anyhow, that's a silly example, but just a good one to showcase that every once in a while you have to find angles when given arc lengths and radii. Anyhow, that'll be it for this video. The next video is brand new material. The next video, at least for most pre-calculus students, is going to be brand new because we're going to start into areas of sectors, and then the following video will be velocities, angular and linear velocities, which is, I think, a wonderful topic.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close. Don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.